Today we're going to go through a structure submitted to us by ADD Consulting in Lurgan. It is the extension of an existing industrial building. It's portalised. This has been built a few years ago. There's some interesting design challenges and some guidance that we can cover through on this type of building. I'll note I've made some changes to the model since I've gotten it. I was playing about for a couple of days on some of the different settings there. This is not design advice. There will be things in the model that probably you shouldn't copy. There's things that I've changed from the original model, so keep that in mind. I'm just going to go through a list of what we're going to cover today in the different modules. So we've got MasterFrame Pro. That is where we generate our 3D frames. That is at the heart of the MasterSeries ecosystem. And we've got all these integrated analysis and design modules. MasterFrame comes by default with our PowerPad suite and our full building design suite as well, as you can see from the table. We will be defining the steel members. I'll be showing you the steel members in the model and the new steel interface updates within MasterFrame. We'll be looking at the support conditions within MasterFrame as well. Maybe talk about some guidance in relation to partial fixities for portal frame designs. We'll be applying the loading within MasterFrame as well. So our snow loading, including our wind loading as well, and the associated updates with the master key wind loading module. Then we'll quickly run through the loading combinations and partial fixities in relation to those different loading combinations. We will also look at our steel design module and all of the upgrades associated within that as well, including the new lean design tools function, which will lead us nicely into our life cycle assessments module at the end. So we'll do a quick demonstration of a report on that. If I jump into the frame, we'll not be generating any new members today. We have got a lot of online content on how to generate frames within MasterFrame. It's mostly carried out within the first two menus here, create and modify. I always like to reference this playlist that we put up last year. It's titled MasterSeries Tutorials MasterFrame. So you can go through, get an overview there. Each video is between 5 and 10 minutes. There's a 15-minute video there, but they're bite-sized introductions to the different functions within MasterFrame to really get you familiarised with the module and really useful for new users. As I say, we won't be generating any new members in here, but we can jump in and look at the new functions within the MasterFrame associated with the steel design module. So we'll start by looking at the steel section selector. We can edit our properties a couple of ways within MasterSeries. We've got our view member property editor, so we can select multiple elements there and edit them within the member properties dashboard here, or we can go into the classic section selector. Here we will be presented with the steel sections selector. In 2024, we've given one of our core tools, the steel section selector, a complete overhaul to streamline its usability and to modernise its interface. For those familiar with the previous versions, the old selector was functional but often felt a little bit cluttered, making it challenging to navigate efficiently. So the new steel selector design, it's much cleaner. It replaces the 3 rows of densely packed controls with a more organised layout. And all the essential features, including haunches, casing, secondary sections, etc., are still present, but they're arranged more logically. So it makes it easier to locate and activate each function when working on your design. So we will be looking at the properties in the member section materials option. On the right-hand side, we've got our different options there for sections. We'll look a little bit at member loading and attributes in a little bit, but for now, we're just looking at our steel selection. I should mention also our recent blog post, which covers all the changes. So it goes through all the changes that you will be familiar with probably in the old MasterSeries and the new. So steel section selector update, our redesigned steel and composite member design groups interface we'll get on to next, and then the changes in the steel module itself. So if I pick, for example, a portal rafter here, we can see that we've got a haunch section selected or predefined, and automatically we get grayed out options. And this haunch, if we turn that off, for example, goes away. In the previous versions, we might have had some of these options showing constantly, taking up screen real estate. But if we turn that on, we can then see other options grayed out, giving us clear indication of what other attributes we can assign to each element. So if I pan through then and select some different elements, portal, a roof bracing member, for example, a circular hull section. We don't have any options there available, just generally arranged a bit cleaner, a typical beam, column, and for each different element you include, you will get an additional menu pop out, fairly useful. We will go to back in the member properties again, and for our fixed supports, let's say we pick one of our columns, we then can go into our member loading, and I've already set up our cases here for our different partial fixities. So the way these works are with loading combinations. So I mentioned earlier, we've got N0. If you refer to the technical guidance note, it's recommended to use N0 for pinned, which is 0% fixity, N1 for partially fixed, 10% fixity, and N2 for 20% fixity. And the use of N1 for 10, N2 for 20 just makes remembering the load groups easily. N prefix probably reminding you that it's a node, and the 0 with the fixity value. So in this case, we've got 0% fixity for N0 on all three directions. So torsionally, minor, and major. This is the top of the member, so this denotes the lower nodal value. So if I turn on my nodes and we're looking at this, we've got node 50 and node 145. So this denotes the base of the column. And for N1 partial fixity, we can specify 10% in the major and then pin it on the minor. I'm going to remove those for simplicity, and we're just going to say 10% fixed in all directions for N0, N1, and N2. So I will show you how they can be applied when we get to our loading combinations, but that is how we will do those for our columns. One thing I should note is I've just changed those for the current member. If I wanted to edit them globally, so I'm going to go into one which also has been defined. I'm going to turn off our grid line so we see these better. So these have all been defined with our N0, M1, and N2, and I may as well change these while we're at it. And that is all these columns with the same attributes defined. And I should also add those. Okay, so and we'll notice in our gable end, our non-portalized columns, we just have them as pinned. And then we can also, if you like, you can review your releases by turning on your release conditions and reviewing there. So, and then you'll see that the base partial fixity is denoted by blue squares at the bottom of the column. So we'll go into our design groups next. Design groups can be used to define a common set of parameters for a group of members. You'll be able to specify that a group of members have the same design brief properties and the same section size. So although they're not essential, they are recommended since they allow for a more controllable and rational design to be achieved, particularly when performing an automatic design within our steel design module. It's got the added benefit that they can now integrate with lean design tools, and I'll demonstrate that later in the steel design module. I would recommend, if you're using these, to change the data for the whole group and make the section size the same for the whole group. You'll notice also that the steel composite member design groups has been reorganized. So the old member design groups will be automatically migrated to the new format. If you remember the old menu, it was a list of parameters and it lacked a little bit of structure. The new layout, we've got our design parameters categorized. So general, axial capacity, lateral torsional buckling properties, lateral restraints, deflection, torsion. These also can be managed within the steel design module, but it's nice to set them up before we get in there, and this new interface makes it easier. In this case, for example, we've got a portal rafter. So if we turn on a 3D view of that, we can specify, before we get into the steel design module, our different parameters. For example, in this case, we've got our top flange restrained. Another thing we'll touch on in the steel design module, if we have both flanges restrained, we will have an axial with moment check. If we change that to a top or bottom flange restraint, we will introduce the Appendix G or Annex BB checks for reversal loads as well. So we'll keep top flange restrained. We've got some stays that have been defined in the steel design module, so you can see how they can be applied later, and then some deflection limits there as well. I'm going to give you a little tip on how to apply snow loads for drifted loads. If we go into our loading menu, they have been predefined. We'll do a demonstration of one here so you can get an idea. We're going into loads, floor and roof panels, and add and edit panels. What has been done here is they've been split up into different panel groups. So there's a standard roof with a typical snow load applied, and then a drifted snow roof where snow could potentially build up. And I think this roof, I don't think it abuts another, it possibly does, in which case it should probably be within the drifted snow gravity area panel group. I'll run through the loading here. So on our drifted snow, we've got dead of 0.5 standard and then a live load of 0.6. We will have the same on our general roof panels, except we will add a K1, which is being defined in our load groups as a snow load. It's pretty much the exact same, except we've got 0.6 and that'll be applied throughout the roof panel. But when we look at our drifted snow panels, we will have to manually apply patch loads for our snow loads and build up. So we've left K1 blank there, and then we can go onto our patch loads and see how they have been applied. So I can delete one, for example, and redo it just to show you guys how it can be done. So I'll delete patch load 2 and we'll redo it. As you can see, the load increases as you get towards the valley. Let's add a new patch load 5. We can say what load group it's in, what value we're giving it. As I mentioned, K1 is going to be where our snow loads are applied. And for load value, it's in kilonewtons per metre squared. I like to use 1 as the default. And then when we're applying a varying load, we can adjust the ratio to suit so that whatever we put in is equivalent to a kilonewtons per metre squared. I will say, let's pick our panels along here. So pick panels, draw, and then we can just click on the panels that are applicable. And we can say, yes, we want a varying load. Let's say it's 0.6 to 1 kilonewtons per metre squared. So a varying ratio of 0.6 on this first 1, 2, and 3 are at 1. So we'll pick our 3 points. So pick our first point, and that'll be 0.6. So that's going to be at ridge. So we can click ridge, and then varying ratio 2 of 1 at our valley, and then that is our loads applied. So you can visually see that. That's our snow loading applied. Next, there's a couple of major updates with the wind loading in MasterSeries. The first is with the site data wind analysis tool. So we have got a couple of upgrades here. We're using new SCIPHYR data upgraded from the old Breve data that we used to pull from. And then we've also got wind CPE variations, which we'll go on to in a little bit. We have our wind loading all set up and turned on. The first thing you'll notice when you go into the wind module is the graphical changes. So it's a familiar layout, but again, in the background, we've got our SCIPHYR site data, and visually you'll see that the categories, topography and roughness category maps from 2023 have been replaced with the Google Maps and satellite terrain options as well. So you can switch between satellite and terrain options on your second map there. We do have a blog post on SCIPHYR that's also been released as well. So maybe you would like to give that a read through. We will have more documentation as we go forward, and SCI also have documentation online in relation to it. Keep your eye out for that. But essentially, SCIPHYR is a web-based API for wind site assessments, similar to how Breve functioned in previous versions of MasterSeries, and it uses NASA shuttle radar terrain mission data for your topography, and it allows for automatic updates of site data and terrain information. Upon opening up MasterSeries 2024, you will get a notification letting you know that you're migrating to a newer version. I'm going to reset this site and show you how to define a new site. So we'll go back to the equator. We are looking to go to Cookstown. I know the postcode of where we're going. Click user define site, and we can either say we've got a postcode that we want to go to, or we can pick a town. The first set of towns are for the UK, and the second set of towns are for Ireland. We have Cookstown in there. We can choose that and then navigate. I'm going to go get a little bit more accuracy and say I know the postcode, so it's BT89DG, and we can watch the map update to that. Now I'm going to turn on the satellite and we can see we're in an industrial estate, and if we go down a little bit we can actually see our building and we can easily refer to it on the map here. We're slightly off here, we're about 5 degrees off, so we can change that and set our frame angle to north at 5 degrees. We can just click on this site, recalculate based on the marker position, and we're confident that we've got a fairly accurate site range. We can change this down to the minimum it goes to is 100 metres. So that is a 100 metre site range from where we're working from. Okay, the other options we have there are Ordnance Survey reference, easting and northing, postcode. You can use air codes as well, latitude and longitude. It tells us exactly where we are here based on the map. We've got 2 circular diagrams based on the chosen site location here. We can look at those in 3D as well. So I'll just go and plan. And the first polar graph displays our roughness category, indicating your structure surrounded by 30-degree segments, and the distances to sea in blue, country in green, and town in red. Roughness is about surface obstructions that impact how wind slows down near the ground. For example, buildings and trees. And fetches are displayed radially from the site on a logarithmic scale. If you look at the first line there, that's 1 kilometre from site. If you look at 10 kilometres there, we do get a logarithmic scale all the way to 100 kilometres here. The building, obviously, it's just diagrammatical there. The red also relates to your obstructions as well. So I'm going to click on our sea, county, town roughness categories there. We can verify that by looking at the 0 degree angle. We can see that to sea it's 62.1 kilometres. So we can obviously see that it's getting closer to your 100 kilometre logarithmic scale than the 10 kilometre. And in town, there we can see it's just under halfway between 1 kilometre and 10 kilometres, which is 3. And if you want to verify that, you can just look at the map and say, right, this is not too far off from what we're actually looking at here. We're countryside to the east, we are town to the north. And then if you actually look and scroll out, we've got a body of water, Loch Ness, and that is captured as well. Now, there's different rules for how bodies of water are captured within the SCIPHYR module, which can vary slightly from what you have in Breve. In this occasion, I think it is the distance to the shore is smaller than the length of the body of water. So there's some BRE publication 436. You can check out some rules on that. But as I say, you can use this to verify the information you're getting on the Google Maps as well. So another comparison, Breve versus SCIPHYR data, you want to understand that a little bit, especially if you're working between 2023 and 2024. So Breve uses a ground roughness to a resolution of 1 kilometre and topography to a resolution of 200 metres. And SCIPHYR uses both roughness and topography to 500 metre resolutions. And you'll also get different altitude values based on those different resolutions. The main technical differences between the old Breve and new SCIPHYR, that'll be detailed in an upcoming blog post and technical note in much more detail as SCI comes out with more information as well. If you have 2023, you will be able to open up Breve and you can get a bit more information within the help menu in there. For example, it'll give you some idea of how it used to work in Breve anyway, and how your roughness categories are summarised within there as well. So, and it gives you information on the different types of obstructions it grabs for the different roughness categories that are defined within your site. There's some notes as well. For example, obstructions here. North of the site, we've got town. Site obstruction data is not taken from a detailed database, but defaults to a 10 metre high at 20 metre spacing for town with no obstructions for country. So you can verify that. If you go at 270 degrees, you'll see no buildings, space of 100 metres. The other useful tool to use is the satellite map. So you can look at your obstructions. I would check that on. If you turn it off, it doesn't include for them at all. When you turn it on, it does. So you can have a look at your site, where buildings are around it, and visually use Google Maps to get an idea of the obstructions around the site. If you know more exact values, you could put them in yourself. The terrain then, it'll be more related to your topography. This is a fairly flat site in its surrounding area. If you zoom out, you'll see you have the sparings to the north, but they're not close enough to be picked up. So it'll assume this as a fairly flat site with no significant topography. So it's nice to verify your obstructions and your topography with the different map types and your location with the Google Maps and the different tones between countryside and town there. The site data tab has been tidied up as well. So an updated layout, a bit cleaner. It's taken some options that were in the report and put them into the site data. You can manage it within there. So the other aspect is the roof CPE signs. Our director, Martin O'Gara, has covered this in a lot of detail in our recent webinar. It's worth having a watch at that. It's less than 10 minutes. Martin goes into depth in it, and there's still some minor development ongoing on this. We will be, again, publishing a blog post on this in the coming weeks as well and giving more information on that. We can look at these by going into our loads, our wind panel loading, our wind panels, wall and roof. So MasterSeries 2023 for different roofs, especially for multi-span dual-pitch roofs. Users had to manually manage CPE signs by creating separate wind directions for each variation, and that will be done within your load CPE tab under the plus minus column. For each wind load case, users would have to configure new wind directions, which was both time consuming, prone to error. So we've introduced this new CPE sign tab within the wind panel setup where you can select one of the 4 patterns for your different roof panel. Here for our windward, leeward, related to the different angle of the wind. We do have a technical note as well that explains MasterSeries uses British Standards directional method in the determination of the external pressure coefficients for use with the software. Other aspects of the wind loading, for example, site wind speeds, terrain effects, etc., they're determined in accordance with the UK National Annex document. That's summarised within here, so you can have a read through that as well. And this also includes the Eurocode actions on structure. So I'm going to pull that up and go to table 7.4 for dual-pitch roofs. For note 1 here, this is a key note. At 0 degrees, i.e. W1, within the model, one coming in this direction, in this case, the pressure changes rapidly between positive and negative values on the windward face at around a pitch of angle -5 to +45 degrees. So both positive and negative values are given. For those roof, 4 cases should be considered where the largest or smallest values of all areas, FGH, are combined with the smallest. So in the windward side and in the leeward face, if we look at the British standards then for the CPE variation for pitched roofs, we can see, for example, I think these pitches vary between 8 and 11 degrees. We can see, let's say we pick 15 degrees, we get both minus and positive values on the windward face, and then if we go down to the leeward face, we've got negative values. So the new CPE sign patterns allow for all the different combinations to be accounted for. So if we check our windward facing sides, we've got pattern 1 and 2 are all negative, all positive, so they're fixed. And then pattern 3 is negative values and in the opposite direction positive. So we can click through our dual-pitch roof and see that those are alternating between the different panels. That will also affect the amount of load cases that we generate. I'm going to next go into your load case generation, auto-generate load cases. I already have load cases set up for this, but I could probably just start again because it'll only take a minute or two and I think you will find it useful. I am going to reference the SCIPHYR 399 document, and it gives some load combinations for portal frames with snow and wind to be considered. So I'm going to keep that open, and then I'm going to keep our automatic load case generator open beside it. So you can see how we can apply our new load cases. So let's reset these to the MasterSeries default. We've got our dead plus live, live only, dead only. I'm going to shift these about a bit. Live only and dead only, we're creating service cases only. And then now we can go to dead plus live. We can see dead 1.35 and posed 1.5, and then equivalent horizontal forces to be included. So we can do that within the load case generator by saying D0 and D1 are included, and L1 is included in this. And we can add equivalent horizontal notional forces as well. For the next, we're looking at dead plus snow. So we've got dead plus live here. We can copy that down. So we could copy, we'll get a copy at the bottom. I'm going to call this dead plus snow. Then instead of checking our live load, turn that off and then scroll to the bottom and check our snow. So we've got D0 D1 and K1. We then have dead plus live plus wind, and I'm going to say plus snow. So dead plus live plus wind in all directions plus snow, and we're going to say that snow is leading. So we can check the leading box there, and that is dead plus live plus wind plus snow. We'll say lead. Now I'm going to copy that down, and we've got a one leading, and it's as simple as unchecking our snow load, leaving our one load as a leading variation. So, and then finally, we are going to check the frame and uplift. So dead plus wind, and we've already got, going to have our permanent as 1.0 unfactored, so we can specify our dead loads as favourable. We can go a step further and specify services as well, and maybe in D2 and completely remove them altogether. And I should have mentioned as well, we've got equivalent horizontal forces that can be included as well. We can also add our one sign patterns that we talked about earlier, so you'll be familiar with the 1, 2, 3 and 4. So for here, anywhere where we've got wind, we can turn those on, and we can preview all our load cases. You'll notice that once we've turned on our pattern loading, we get a lot of load cases worth keeping in mind. So dead plus wind as well, we can do it for that. You're timing your number of load cases by 4 for each load group you have there. But that's how easy it is to set up your load cases for your portal frames as well. So let me see how that looks. So preview, 292 load cases. Well, we've got existing there as well, so remove 112 or so, and we can go back. So we can replace those and see that we've got all those load cases. The other thing I would also like to show you is the specified partial fixities for our supports earlier. So we can go into our load combinations, and without having to go through the naming, so node 20% fixity, instead of doing this for each, we can go into add or remove load group in multiple cases, click on edit. Let's select all our ultimate cases, and we're going to add N not, so fully pinned fixity on those cases and apply. And then we can do the same for N2 for our service load cases. Add N2 20% fixity for deflection checks, apply. And then we can review those by going through. We can see N not an N2 bouncing between. So we can add N1 as well. We'd have to go through and do some additional analysis checks, but it's more so to give you an idea of how that can be done quickly and easily in reference to partial fixities. We're going to talk through the steel design updates and talk a little bit about MasterSeries LCA. So again, you can refer to our blog post, which goes into detail on the new modernised steel design interface. I will talk through it here now. We'll do an analysis on that. So we've got a significant visual improvement on the old interface, similar to the section selector that we looked at earlier, which includes modern iconography and elements grouped into more intuitive boxes. And then you will see that here. And then again, layout panels for less commonly used inputs, again, to save space and declutter the interface. We've got our axial moment design data, again, similar to the design groups that we looked at in MasterFrame. There are clear subcategories in line with the design group settings. And then our lateral restraint tab, we've got a portal member selected here. We can maybe do a quick example check on this design here. So we've got the merging of the axial with moment check and the unrestrained compression flange checks, previously referred to as Appendix G or Annex BB checks. They can be a simple axial with moment check with lateral restraints. We've got 1.8 meter spacing between different lateral restraints here, or we can say those are lateral restraints apply to the top flange only in the example of purlins on the roof. We then would have to specify our stays manually on the bottom flange with the new lateral restraint tab that opens up at the bottom there. We can go and check your axial with moment checks for each of the different sections, and then check your bottom flange checks there within all in one place. We've removed the 9 portion restricted. We can specify our equal spacing, our restraint side. That's the main changes with our design briefs. We can look at obviously our strut and tie checks. Again, an improved layout with both the brief and section sizes tab and our strut and tie design data tab, a lot cleaner. I'm going to also introduce you to the load cases and group set. Before, you could change your load cases and case sets within the steel design module, but you're restricted to just your default case set. You can now create sets for ultimate or serviceability. Loading cases, MasterSeries generally manually pick that up. You can use your load sets there as well, which aren't actually in use in this here model. And finally, our lean design tools, which is a really nice feature. This hammers home the use of the MasterSeries steel and composite member design groups for rationalising your design into different groups, identifying which members might be suited for another new group, having their different properties. Whenever this comes up, it has to analyse the full frame and just do a full check on all the members first before it spits out the table. It'll take a second there. So it'll list all your unity ratios in the one place for the full building, and then from that you can identify which elements or members can be changed for more efficient grouping. Okay, that's us. So this is the Lean Design Tools report, giving us all of our briefs and brief type and different members, length, section size, total mass, efficiency score, IE utilization ratio, and then estimated waste for your different members. So you might have an inefficient element, which brings your efficiency score down, but you might only be wasting a few kilograms. So it's worth digging into these different numbers. Or you could have a fairly efficient member, but with a lot of wastage, for example, your bigger members. We can see that on the full frame. We can dig down into different design groups. For example, let's pick this portal rafter. We can click on current design group only, and we can see our efficiency score is over there because our utilization ratio is over. We'll do is an automatic design of that. That'll update the section. That tells us that we're designing to this member, which is the worst case, but we can see that one of the members in the same group, i.e. this one, it's really inefficient now, and based on this efficiency score, we're wasting quite a lot of steel there. So that would suggest that we should put this into a different design group or create a brand new design group. So we can see as well at the bottom there, the total weight for each of our design groups, how efficient on average this design group is, and then the standard deviation efficiency score. So that tells us basically how good your grouping is. So there's a large enough variation within that. We should probably just look at changing those. If we go on to another one, we can see again, we've got some failures there. Do another auto design on that. We'll have to do a re-analysis of this frame when we change our different section sizes. You can see one of these members is only 50% utilised. You'll be able to see the wastage with these different elements as well. So a really useful tool, and it'll nicely lead us into the MasterSeries LCA demo. There's big incentive for not only regulatory incentives, but financial incentives for being able to produce carbon calculation reports with your superstructure, substructure for going forward, as they do contribute to BREEAM assessments, which look to be coming in through local authorities throughout the UK in the coming years. So if we go back into MasterFrame, let's go into our BIM exchange and go to MasterSeries LCA. I've got a project set up already, predefined Ballyreagh Workshop. I've guesstimated a budget. You can put that in, and from that you'll be able to get some values out in the report, because they're able to measure construction activities based on the value of the project. And then I've given an area of the building. So that's a general internal area for buildings and a net internal area for offices. So I'll go to next. I'll call this report, let's say, Lean Design 2. I think I've done one before. We could do it for whatever phase that we're looking at. In this case, it's an evaluation. So we could retrospectively say we could have made it so much more efficient by doing X, Y, Z. We'll take some default values for steel and concrete. So that'll pull up a web page. That'll bring us to masterseriesLCA.com. I've already got our project set up, our Ballyreagh Workshop. We've got a couple of reports there existing. I'm going to look at this most recent report and just take you through it. So the phase floor area, which we've defined, we can write a description on the report and then any notes, assumptions, scenarios. The really interesting part is the data. So I'll take you through each of the different items. We've got the steel frame here. So you will see all the different steel elements come through. So we've got 50 rows here. So we've got 68 different rows. Our item is a description of the item that we've exported, the weight, the element that it's in. So superstructure, frame. We can split that up into upper floors and roof if we need to. For example, we could search through the notes on that, and from MasterFrame, we've got our roof level defined. We know that that's a roof element and be able to break down all the different categories within the building, but we'll leave that out for now. So we've got our element, our service life in years. We'll just take the default 60. Our waste rate percentage, typical value 1. There is some IStructE guidance called A Brief Guide to Calculating Carbon, and that's from the IStructE. So you get some values in there for your different parameters that we'll go through right now. So waste ratio, transport, I just turned on bulk edit there, I've selected all, and then I'm saying I want to edit the transport. I'm going to add a journey from, let's say it comes from Europe. We can say goes sea and it goes 1,000 kilometres to port, gives us a default value there. We can add another journey, road, average laden. Let's say it comes 200 kilometres from the port, and we get a value for that as well. So we can review that for each one. The next is the end of life scenarios as well. So we can, again, bulk edit that, click on the end of life scenario and tell the report how the steel, what's going to happen at the end of its life. So if it's reused, I think some typical values might be 10% can be reused. There's no kilograms of CO2 per kilogram to account for within that. Recycling, you'll get those type of values probably from the IStructE guide. We've actually got a minus 0.9. because we're going to be able to reuse that. And then we're going to say about 85% of that's going to be recycled. Incineration, I do have a value of around 1.6 kilograms of CO2 per kilogram, but we're not going to incinerate any of this steel, and the rest will go to landfill, which is a value of around 0.25, which I have. Again, these aren't actually from the IStructE guidance, these are general values I found, but you can put in more accurate values based on what you know. We can go on to other different options within there, energy, water and activities. We'll use some default values for them within the report, and then we can look at the results then. And we are introduced to all the different charts for this particular report. These are best compared against another design. For this design, the only other ones I've done are just changes in section sizes. You could do a completely separate design and a rearrangement, a different layout, and then you can do a proper comparison. But for this, I look at my different reports, and let's say we want to compare our most recent lean design with original design. We can say lean design 2 with our original design and do a comparison. There won't be much difference in this one because, as I say, it's pretty much the same arrangement, same layout, just different steel section sizes, really. But I think you'll be able to see the value in it and how easy it is to use with MasterFrame. And there's the trial version of this is a 30-day free trial. Getting used to using these now for upcoming regulations at the very least, never mind the added value it can give you by being able to get on BREEAM assessed green buildings, and especially in combination with the lean design tools and how useful you can see that is. You'll hopefully get a bit of an edge on the market. So that concludes my presentation. So Andras, did you have some Q&As that you wanted?
Just jumping in here, it's Martin O'Gara. Just another question there that I thought was quite an interesting one. Patrick did some covering of the partial base fixities, whereby we had traditionally a 0% partial base fixity and ultimate and a 20% partial base fixity for service cases to reduce that deflection. There was also a 10% partial base fixity, and Peter's asked the question about where that 10% would be used. That is traditionally more so used in the British Standard Code for sway only loading case, where the sway only case only has horizontal notional forces applied to it purely for the purposes of the calculation of the elastic critical load factor. So you can get a benefit really to reduce your elastic critical load factors by including a 10% fixity to reduce those sway deflections, which is obviously what drives the elastic critical load factor calculation. Less so applicable to the Eurocode because its method of calculating the elastic critical load factors is more built into the ultimate loading combinations through the ratios of the vertical and horizontal load with the deflections associated with each of the ultimate cases. So it wouldn't be so appropriate to use the 10% there because you are working with your ultimate load combinations in the calculation of that. Interestingly, a piece of work that we're just about to include in the latest MasterSeries 2024 version actually takes a step back from that method of calculating the elastic critical load factor through the ultimate Eurocode loaded cases. And the SCIP 399 that Patrick referenced there goes into a bit of detail about how that's not always the most appropriate type of load combination to assess the elastic critical load factors for portal frames due to their natural horizontal movement under dead load only, where the columns spread horizontally. So you're not really looking at the sway mode load case there. And that actually recommends you do step back to the British method of assessing the elastic critical load factor if you are doing it by the deflection method. So our latest MasterSeries 2024, the up and coming patch that's going to be released, will include some work on that and a bit more control over which loading cases get used for the assessment of elastic critical load factor as well. But we'll release a bit more information on that through our blog post channel to discuss that in a bit more detail. Really interesting topic area that actually.
So, ladies and gentlemen, I would like to thank everyone for attending today. I hope you enjoyed and learned in this presentation, and see you at our next webinar. If you have any questions, you can get in touch with us on our usual channels. If you want to try out the software, just go to the MasterSeries website, fill in a request to do so. Thank you very much for attending, and have a great day.